In this class, we're going to consider using algebraic formulas. So we know that a formula is just a way of mathematically representing a rule, a set of instructions, a way of carrying out an operation, and rather than having to write it out longhand, literally in words like we used to do, back in the day, now we've got this idea of symbolic algebra, so we can represent in very compact algebraic form the rule. So the rule gets expressed in mathematical notation rather than in words. So let's say that our rule is to, I will write this one in words, so let's say our rule is to take a number and we're going to multiply the number by 4 and then we're going to subtract 3. So that's a rule we want to express in an algebraic formula. We know that to do that we've got to use a variable, and the variable is the number that you're imagining in your head. So if I tell you take some number and multiply by 4 and subtract 3, then that some number, that is your variable, because that can be any number. It's coming out of your head, it can be anything. That's why it needs to be able to vary, so that's why we call it a variable. So usually we'll use the letter x for a variable, but it doesn't have to be x. So in this case, we want to take that variable, multiply it by 4. Well, how do we represent that? Well, that's just 4x. Then we want to subtract 3, so that would then go there like that. That's how we create the algebraic formula. How do we actually use it? Well, we use it by starting to substitute in actual values for the variable. So it depends on the context as to what you're trying to achieve using your formula as to how you'll sub in the values. But just to get a feel for how this works, let's say that we want our x value to be 1, and then we're going to let it be 2, and then we'll let our x value be 5. Let's say for some reason this formula is interesting to us and these values for x are interesting as well, and we want to know what happens when we substitute those in, when we actually use the formula. So these are called the input values. When we put them into the formula, we're going to get the output value. So for this x equals 1, that would give us, well, 4x, remember, is representing the multiplication by 4. So 4x really means 4 times x. X is 1 now, so that's going to be 4 multiplied. This is a multiply sign now, not the x. So 4 multiplied to 1, and then we're going to subtract 3. So just be careful if you're doing a calculation like this to maybe use brackets, parentheses, just to separate out the order to avoid confusion. So here, 4 times 1 is 4, minus 3, doing that calculation gives us 1. So when x was 1, when we put that 1 into this algebraic formula, we get 1 out as the output value. When we put 2 in, just doing the same thing, it's going to be 4 multiplied by 2. Then we're still going to subtract 3. The 3 is called a constant here. The 3 never changes, so we're always subtracting 3. It's not affected by the variable, the 2. 4 times 2 is 8, minus 3 is 5. So the output variable when x is 2 is 5. So this is an example of using an algebraic formula. We're using the formula to input these values and get output values on the other side. Some people like to think of formulas as input-output machines. It's not the worst way to think of it. You put some number into the formula, it does something, it performs the rule in this case being multiply by 4 and subtract 3, and then it spits out a number on the other side, like some kind of algebra machine. So here, just letting the x be 5, so it's going to be 4 times 5. 5 is the value of our variable. Taking away 3, subtracting 3 again. 4 times 5 is 20, take away 3 is 17. So that's just a very introductory level question in using an algebraic formula. So that's an abstract idea. I mean, an abstract sort of formula. It doesn't mean anything. I just made it up, imagining some variable x. We saw in previous classes the formula for conversion of temperature. So C equals 5 ninths. So 5 ninths F minus 32. This is a good little example. So let's imagine that you wake up one day and it's 100 degrees Fahrenheit and you want to convert that. So this would be an example of being able to use a formula in an actual practical way. So if you wanted to use this formula to convert the temperature, then you could just do so in the same way that we use this made up formula here. So we know the F, which is our variable here in this formula, is going to be 100. So we can say, right, well, we can let C will equal 5/9, put in the 100 in there for the f, minus 32, and then we just go ahead and calculate that. If you calculate that all the way down, it comes out to be 37.8. So pretty warm, yeah, 37.8. So yeah, so that would allow you to convert. Now, that's just a more real world and maybe slightly more complex example than this one, but it's essentially doing the same thing. But one thing you'll soon learn to do with formulas is to go the other way. So let's say this question had been posed that if the temperature was already given to you as C equals 37.8, then what would be the temperature if you wanted to make that into Fahrenheit? Well, this is where this formula sort of in a way breaks down, because it's set up to go the other way. It's set up so that your input is the F value, and then the output is the C value. Here the input though would be the C value and the output would be the F value. There's no reason to not use the formula the other way, but when we do that, we call it, well, the process is called changing the subject of the formula. In this formula, this is called the subject. This is the thing we're trying to get out of the formula, but here we want the F to be the subject. You can do that by reordering the equation. That's beyond the scope of this class, but just be aware, it's really important at this point, even though you're just starting out with algebraic formulas, that formulas can always be reworked the other way around, so that you're sort of reversing the direction, so that your input value becomes your output value. And you'll certainly learn that quite soon, actually, in this class here in Algebra 1. That's a really important operation. Let's just look at one final example. So let's say that you had something like, I mean, algebraic formulas can be such that they contain all sorts of different shapes and size. I mean, they come in all sorts of shapes and sizes. They can contain all sorts of different numbers, and they can contain fractions and whole numbers, and they can contain different operations. But let's say you had something like, I don't know, something like just something like this. So when you've got something which contains multiple terms, you've got to be a little bit careful with the order of the operation. So here, for example, this is telling us to take our input value, the variable, x, whatever that would be, square it, and then take away from that 4 times that x value again. So just to use an actual example there, let's say this was your formula. This is your algebraic formula that you've been given in a question, and you need to work out the value this formula would give you when x equals 3. Okay, well, how do we go about doing that? Well, we just do what we did here, and we just do what we did here. So we would just say, right, well, when x is 3, we're replacing the x's, the variables, with 3. So it's going to become, oh, sorry, I was going to write an x there again, but this is going to become a 3 now. So our variable is no longer a variable, it's become an actual number. So it's going to be 3 squared minus 4x, remember, 4 times x. So it's going to be 4 times 3, 4 multiplied to 3. I'm just going to put that in a bracket. And the bigger the formula, the more terms it's got, the more calculation you'll have to do when you substitute numbers into the formula. So just taking this forward, 3 squared is 9, 4 times 3 is 12, so it's going to be 9 minus 12. That's going to take us into the negatives. The answer there is minus 3. So the reason I wanted to show this example, it's not a million miles away from this one here, but it's just starting to get a little bit more complex. And if you've got multiple terms containing the same variable, you just substitute that same variable into both. You can't have, for example, a 4 here and a 5 here, because they're both x. They both have to represent the same numerical value for that variable at the same point in time. So when you're just starting off with formulas, they don't have to be particularly complex. Just get a feel for what they do. And what they do, and it's really important to remember this, is they allow you to mathematically represent a rule. A rule is just an operation, it's a set of instructions, and even if your formulas start to get far more complex, even more complex than this, don't lose sight of the fact that they are just a rule. They're an input-output machine. You're putting some number into the formula, it performs a rule, and it spits some number out the other side. That is essentially what a formula is. All the things you'll learn to do with formulas, like rearranging them, you'll learn in due course. So at the moment, just getting that core idea down of what a formula is and how to start using algebraic formulas.